Chemistry 101!
For our gaseous solutions, we will have two examples. The first one will be
the water cycle, which is a continuous cycle where water evaporates, travels into the air, and becomes part of a cloud. Then it will fall down to earth as precipitation, and then it will evaporate again, and this will go on and on and on, which would be like a never-ending cycle.
For our second example, we will do
basically our solution would be the atmosphere, and our solution for the water cycle would be the water vapor, but our solution for our next one would be the atmosphere, which would have the nitrogen as our solvent, and our solute would be oxygen or anything else that we like breathe in. It can be anything basically.
That's in the atmosphere.
In that aspect. And our solution would just be the air or the atmosphere. And that is an explanation of our gaseous solution.
For our liquid solution, our solvent is our liquid, which is water. We will add the Kool-Aid powder, which is our solute, and mix them together, and we will end up with the liquid solution because no chemical change was made.
Now we not only have a liquid solution, but a tasty drink.
We will be making brass. Our solvent is our zinc. And our solute is our copper. When heat and pressure are applied, it will make brass, which will still be a solid solution. We will use salt and water to make a solution. This can also be an aqueous solution because we have water as our solvent. First, we will put our water, which is the solvent, that allows other substances to dissolve or become incorporated into the liquid to form the solution in the cup. Then we will add the salt, which is our solute, which will be dissolved in the solvent because it's soluble to make a homogeneous mixture, which would be our solution. The amount of solute is an important factor because of the solubility to be dissolved in the solvent. Our solution can have a solute that can be added or dissolved, which is a salt or anything you want to use, which can make it unsaturated. So, this is our solution. If we continue to add more solute to our solvent and mix them together, but no more dissolving can be done, then we'll have a saturated solution, which is happening right now. That's our solute, not dissolving.
Nice to meet you, Dad.
Nice to meet you. To demonstrate our surface area, we will take a sugar cube and a grain of sugar. The grain of sugar will dissolve first.
Why is that?
Because the grain of sugar has less surface area than the cube, so the solubility of the sugar will determine what will dissolve first, which would be the grain of sugar. Since water is polar, the molecules of the water are more attracted to other polar molecules. That is why the sugar has a high solubility in water. So here we will demonstrate. Emma, you take the cube, and I will take the grain. Keep in mind I can't grab 1 grain of sugar with my fingers, so I tried to grab the best I could. So 1, 2, 3. There's the sugar cube. Where's the grain of sugar? It must have dissolved. Anyway, that will be a big difference.
Our next demonstration that we will be showing will be an insoluble solution. Our solvent is our water, and the substance that we will be adding would be sand. Now, as we mix it together, it's not dissolving because sand is the substance which will make this solution an insoluble solution.
Next, we will use water to show polar and oil to show the non-polar. Why is that? Because the molecules of a polar solvent, which is the water, are attracted to other polar molecules, so that is why the oil and water do not attract to each other. So we will show that in this demonstration. Here's our oil, here's our water. The water is on top and the oil is sitting on the bottom. If I stir it, they will not mix together because of the polar and non-polar molecules. The oil is still on the bottom, the water is still on the top. Now if we add food coloring, it will really show us. Maybe add 1 more drop. Stir that. Now you can see that the oil is still on the bottom and the water is resting on top due to the polar and non-polar attractions.
Okay. Now we will add our solvent, the boiling water, into the cup. We will add our solute, 3 tablespoons of solute, the borax, to the boiling water to make our supersaturated solution. Now we will just stir it for a little bit for them to be mixed together. For the borax to dissolve. And where's the food coloring? And we'll add food coloring to it so we can see the crystals in a few hours. Must stir that too. It's pretty dark blue. And now we'll leave our supersaturated solution set for a few hours and then record the results.
Thank you for watching. I hope you learned something. Stay tuned for our chemistry 102.